Hi chemists, my name is Kim and today we are going to be talking about how to identify what type of organic reaction is occurring if we are given a chemical reaction equation, as in the chemical formulas of the reactants and the products. We also might just see some questions that ask us in words what reaction might be occurring if it describes the reactants or the products. Now, the main organic reactions that we are going to be focusing on, there are many more types than this, but the focuses for us are going to be addition, sometimes known as synthesis. It's very similar to synthesis in our other types of reaction types that we've learned about. Substitution, polymerization, esterification, fermentation, and saponification. And the final that we'll touch upon that you've already heard about in chemistry class this year is combustion. So as you can see, we have 7 reaction types. No time to waste. We're going to get right to it. Get ready to take some notes because really you just need to look at a couple of examples of these reactions and think about how you can notice patterns as we go on. The first type of reaction we are going to look at is called an addition reaction. You can recognize an addition reaction because it is generally a reaction that combines some sort of alkene or alkyne, something that is unsaturated, contains at least one double or triple bond, with some other molecule. And oftentimes we then end up with adding on to our hydrocarbon chain. So we end up going from an unsaturated hydrocarbon to a saturated hydrocarbon, creating those new bonds between carbon and whatever we are adding to the hydrocarbon chain. Next, we'll look at a substitution reaction. It's not that different from a single replacement reaction in some ways. Notice that one of the hydrogens on methane has been swapped with one of the chlorines in that Cl2 molecule to become chloromethane. So chlorine has taken the place of a hydrogen, and hydrochloric acid, HCl. So that's a substitution reaction. One of another element is taking the place of a hydrogen on a carbon chain. Next up, let's look at a polymerization reaction. Poly means many. So let's imagine that we had many ethene molecules. Ethene is carbon double bonded to itself in a 2-carbon chain here. Imagine if I took n number of ethene molecules. Let's say that number is 1,000,000. And I broke that double bond and bonded them together to form one huge long carbon chain that has repeating structures here. This would be called polyethene. I'm taking a monomer and I'm repeating it over and over and over and over again. Here's another example of polymerization. Styrene, it's showing you've got a benzene ring there connected to a carbon that's double bonded to another carbon. That styrene can also be polymerized and become polystyrene, which is a type of plastic you might be familiar with. Essentially, with a polymerization reaction, you are just taking a small monomer and making it repeat itself over and over and over again, and it often also involves the breaking of a double bond. Next up, we have an esterification reaction. This is a type of reaction where it is useful to recognize a general formula. In an esterification reaction, we take usually an alcohol and combine it with an organic acid. So I've got my alcohol here outlined in green and my organic acid outlined in orange here. And they react to form an ester plus water. So the box over on the reactant side is showing you where the water is coming from in my reactants. That water is breaking off. And then the alcohol and organic acid are joining together to form an ester. So an alcohol plus an organic acid reacts to form an ester plus water. That is esterification. Another way to remember it is that it is a reaction that is making an ester. A third reaction type is a next reaction type is fermentation. I like to remember fermentation as a process that produces alcohol because you may have heard people say that wine is fermented grapes, or that beer, it happens after yeast have had a chance to undergo fermentation reactions. Generally in fermentation reactions, carbohydrates become alcohols plus carbon dioxide or lactic acid plus carbon dioxide. Fermentation produces alcohol. A fun reaction is called saponification. It's fun because it's a reaction that can make soap. In a saponification reaction, you can recognize that it's occurring because you take an ester and react it with a base, for example, potassium hydroxide, which makes an alcohol. So here's an example of isopropyl alcohol, and then soap. Don't worry too much about what the soap looks like. Essentially, the soap contains a hydrocarbon chain as well as a ionic end. So notice we've got oxygen ionically bonded to potassium at all those ends there, which can help to wash away both polar and non-polar parts of stains. So saponification, you're looking for an ester plus a base, making an alcohol plus soap. It's different from a fermentation reaction, even though they're both making alcohol, because in a fermentation reaction, the other product tends to be carbon dioxide. Whereas in this reaction, the other product is a soap, which is usually a bit more complex of a formula. It won't just look like carbon dioxide. And then a final reaction type that involves organic molecules, you will recognize a combustion reaction. You take a hydrocarbon, and that hydrocarbon could also contain some oxygen, so it could also be an alcohol, and combine it with oxygen, and your products are always carbon dioxide and water. So combustion reaction, hydrocarbon plus oxygen reacts to form carbon dioxide and water. Let's do some practice problems. What type of reaction includes esterification and polymerization? Decomposition, neutralization, organic, or nuclear? This is like almost a trick question. It's so straightforward, right? There would be an organic reaction. Esterification and polymerization are both types of organic reactions. They're not nuclear reactions. Decomposition is a type of chemical reaction, and neutralization is an acid-base reaction, also a type of chemical reaction. So organic reactions include esterification and polymerization. Let's try another one. A reaction between an alcohol and an organic acid is classified as esterification, fermentation, saponification, or substitution. I'm going to put a copy of table R right here because that might help you think about it if you can actually study what an alcohol looks like and what an organic acid looks like and think about what it would look like to put them together. So this would be an esterification reaction. If you take an organic acid and you kind of chop off part of it and add in an alcohol, you could imagine you would end up with an ester, right? An oxygen in the middle, continuing on next to the carboxylic group. So an alcohol and an organic acid react to form an ester. This is esterification. Which terms here represent two types of organic reactions? This would be number 4, saponification and fermentation. Deposition is a phase change. Sublimation is also a phase change. So the only combination of two organic reactions are saponification and fermentation. Longer question for you here. You're probably going to want to pause the video to think for these 3 free response questions. In industry, ethanol is primarily produced by 2 different reactions. One process involves the reaction of glucose in the presence of an enzyme that acts as a catalyst. The equation below represents this reaction. In another reaction, ethanol is produced from ethene and water. The equation below represents this reaction in which H2SO4 is a catalyst. Industrial ethanol can be oxidized using a catalyst to produce ethanal. The equation representing this oxidation is shown below. So first, identify the element that causes the reactant in equation 1 to be classified as an organic compound. Next, identify the type of organic reaction represented by equation 1. And finally, explain why the hydrocarbon in equation 2 is unsaturated. So pause the video if you need more time. So the element that causes the reactant to be classified as an organic compound is carbon. Remember, carbon is what causes us to classify certain substances as organic, carbon containing. The type of organic reaction represented by equation 1 is going to be fermentation. I have glucose, which is a sugar, becoming alcohol, ethanol, plus carbon dioxide, which is fermentation. Finally, to explain why the hydrocarbon in equation 2 is unsaturated, first off, I need to identify the hydrocarbon that they're talking about. So equation number 2, the hydrocarbon is CH2CH2. Now, unsaturated means that it must contain at least one double or triple bond in its carbons. The question gives me the name of that particular hydrocarbon. It says ethene in the paragraph above. So I know that an unsaturated hydrocarbon contains at least one double or triple bond. Ethene, I can tell from the ending of the word, ene, that means it is an alkene, which means that it has a double bond in it. So this makes it unsaturated. A final question for you here. The equation below represents the reaction between 2-methylpropene and hydrogen chloride gas. Identify the type of organic reaction represented. Notice that in this reaction, a double bond is breaking. I only see single bonds or fully saturated carbons in my product. I also see that there are 2 reactants and only 1 product. So this is going to be an addition reaction, otherwise known as a synthesis reaction, 2 reactants becoming 1 product. The double bond on the second carbon is breaking, allowing for a hydrogen atom and a chlorine atom to bond into the molecule. So this is an addition reaction. I told you, didn't I, that it was going to be a lot of reactions? Let's check back in on our learning goals. Look at each of these reactions and think about how comfortable you feel identifying whether or not one of these reactions is occurring. The best way to do problems like this is to just practice. So seek out more sources online for you to do some practice if you're still not feeling fully confident. Nice job today.